Welcome to the FP and Haskell Buzz section of Fundamentals of Practical Haskell Programming. In this section, we will learn about why we're here, some basic terminology, and some motivation for learning functional programming in Haskell. We'll talk about some of the real-world issues facing us in our work as software engineers. We'll briefly summarize a few of the issues that affect our daily work in software, and we'll then skim the surface of functional programming in Haskell itself and get a feel for what Haskell programs look like. Problems FP and Haskell can address. At this point, we're all set up with a working Haskell stack development environment. However, while this is a course on practical programming in Haskell, we do need to take some time to reflect on why we're here. At this point, we're all set up with a working Haskell stack development environment. However, while this is a course on practical programming in Haskell, we do need to take some time to reflect on why we're here. This video and others in this first section will therefore be a little more wordy and a little less codey than the remainder of the course. Still, it's worth developing the motivation behind learning a new programming language as well as a whole new style of programming. I'd also like to offer up this video to you as a kind of elevator pitch. At some point in our careers, it's possible that we may be afforded the opportunity to influence the choice of technology for a new project. So please feel free to steal ideas from this video and others in this section for the purposes of convincing managers of the benefits of adopting Haskell or FP. Think of this as a manifesto for functional programming in Haskell. We've already seen one abbreviation, namely FP, which is short for functional programming. Another abbreviation we will see a lot in the literature is PL for programming language. Both terms will be repeated many times and both are rather a mouthful to use, so we'll start abbreviating them right away. Other terms will crop up along the way and we'll define them as we encounter them. Let's just say it. Software development is hard. It's also critical to the functioning of so many systems that we rely on in our daily lives. People also rely on our products, so it behooves us to do the best job possible. Importantly, there is no replacement for competent developers or a coherent design. And furthermore, learning a new programming model such as FP or a new PL such as Haskell isn't suddenly going to fix all of our bugs. However, we should not make it unnecessarily difficult for ourselves to do our work and to build the best systems we can. Let's talk briefly about the ilities. Ilities refers to an arbitrary set of abstract notions that we can talk about to describe the complexity of programs and software development in general. Reliability can be many things. One measure is how effective a PL is at detecting at compile or development time problems that could in principle have occurred at runtime instead. By catching such problems even before the program is run, let alone shipped to the outside world, we will prevent program failure and avoid souring our relationships with our customers. Tractability relates to how a PL allows the developer to break a complex problem down into understandable chunks. It also relates to how naturally a PL allows us to express a solution to such problems. Composability relates to reusability, among other things. One measure is how straightforward it is to combine pieces of a program together into the larger program. Allowing these individual components to be reused by other parts of the program, other people, is also a valuable asset. Maintainability can refer to many things. One measure is how comprehensible to future developers a given piece of code might be, and how difficult or straightforward it might be to fix bugs in it. Concurrency and parallelism, which is a related concept. These are increasingly important in this age of multi-core. How well a PL allows a developer to express concurrency and minimize bugs in concurrent and parallel programs are important factors. Abstraction relates to how well a PL allows us to model a system at different levels, from the finest grained low-level system code to higher-level user-facing UI, as well as its architecture. Typically, FP languages provide distinctly different mechanisms compared to OO languages for dealing with these complexity issues, where OO means object-oriented language. They are not necessarily better, though they often are. So again, why are we here? I'm hoping that everyone here is striving to be the best programmer possible. Most of us will have technologies or paradigms that we're already familiar with. Such approaches to programming might include imperative programming, structured programming, procedural programming, or, wait for it, object-oriented or OO programming. We may also be familiar with such languages as C++, Java, C#, Python, Ruby, and so on. We could just stick to these and work on becoming as strong as we can in the areas that we're already comfortable in. However, I strongly believe that learning something completely different can achieve nothing but good things. Furthermore, all the PLs I've mentioned above are fairly traditional OO programming languages. Some have static type systems, while others are dynamically typed, but they're all really the same. They're also all really the same in that most of them have gained functional features over time or had them right from the beginning. Most, if not all, support something like lambdas, anonymous functions, or code blocks. Most, if not all, also allow us to use higher order functions and FP-style abstractions, though sometimes the syntax does get in the way. Others have also stolen wholesale from existing FP languages. C# has LINQ, which takes its inspiration from Haskell. C++'s standard library has had its algorithms header right from the earliest days of the STL, and these are strongly functional. And in fact, large parts of the C++ standard library ignore classes altogether. Even Python has taken constructs such as list comprehensions almost verbatim from Haskell. I would therefore suggest that there seems to be some value in learning from the source of this inspiration. FP has also been around for a long time and steadfastly refuses to die. Such a statement could be used to justify the use of almost anyone's favourite PL. However, I believe that FP and Haskell are coming of age and are now well established in real production systems. Even if we're forced to continue to use our mainstream imperative or OOPLs, we command a whole new perspective on solving problems, and FP and Haskell will allow us to appreciate problems in a different way. But really, why? I could talk and talk and talk about the justifications for learning FP and Haskell all day long. One thing, however, eclipses every other concern, and that's that programming Haskell is fun.